Okay, I can't tell if it's recording or not. Okay, it is recording. Good. All right, so now we're going to talk about how we write our compound. So remember, a compound is going to be two atoms that are bonded together, whether that be two of the same atoms or two different atoms. So we're figuring out how to write those compounds specifically. So binary ionic compounds are going to be two different elements that are bonded together due to the formation of the ion. So it is a compound, but the ionic part tells you why they are bonded. They're bonded because we formed an ion. Now, typically for this ionic compound to occur, it has to have a metal and a non-metal. So in those spaces, you're going to put metal and a non-metal. So remember, a metal is going to be on the left side of the periodic table. So example of that might be aluminum, or it might be potassium, something like that. And then a non-metal are some of the elements on the right side of the periodic table. So that might be argon or chlorine, fluorine, something like that. So for an ionic bond to occur, we have to have a metal and a non-metal. And the example I have here is aluminum oxide. So we have aluminum that is ionically bonded to oxygen. Now, how exactly do we write this? Usually you're going to write the symbol for the ions side by side. This is just a way for you to represent the charges and get to see everything objectively. And the cation is always going to go first. I didn't make up this rule. This is just how it is. Then you're going to cross over the charges, so the numbers only. So you're going to take the numbers and cross them over only so that the numbers switch. These are going to be what your subscripts are. So those are the numbers that are really small that are below your element symbol. Then you just have to check the subscripts to make sure the numbers can't be simplified anymore. So say you had, let's see, Mg, so magnesium, Mg2O2. So say you had something like this. That wouldn't happen. It's just a little redundant. So what they do is reduce it. So they reduce it to MgO. So that's what they mean to simplify. Okay, so let's try it. We want to write the ionic compound formulas for Be2+, so that's beryllium with a 2+ charge, and chlorine, which is Cl with a minus charge. So what we were told is we have to write the symbol for the ions side by side. So I have beryllium 2+. I have chlorine 2, nope, not 2, just minus. Second step says I need to cross over the charges, but the numbers only. And the cation always goes first. And then those numbers will be your subscripts. So cation goes first. So I'm going to leave some space so I can write the numbers. And I'm switching. So I'm taking this 2 and I'm bringing it over here. So that's where my 2 goes. Now this just has a minus. If there's no number there, we automatically assume that it's 1. But chemists don't like to write numbers if they don't have to. So typically you'll just see it as a minus. So this one's going to cross over to here. So we get a 1 there. So what we are getting for our formula is Be. We're not going to write the 1 because, like I said, chemists don't like to write numbers unless they have to. So usually if we have a 1 there, we don't even include it. So BeCl2 is our answer. So that's how we would write that compound. So later on, we'll maybe explain why we have to have 2 chlorines to match with 1 beryllium, but mostly it has to do with balance. So the chlorine to balance the beryllium needs an extra one. Okay, so I'm going to pause for a second. You try to write the ionic compound formulas for calcium with a 2+ charge, so Ca2+, and oxygen with a 2- charge, so O2-. Okay, so we've got calcium 2+ and oxygen 2-. What we do is we have calcium with its charge, we have oxygen with its charge, then we write our cation first with oxygen, they switch, so we end up with a 2 and a 2. But remember, scientists don't like to write numbers unless they have to, so we can reduce that to CaO. Now try the last one on your own. I'm not going to do this one, so you'll need to practice that one on your own. So with that, we are done with practicing binary ionic compounds. So what you will need to do now is complete the assessment that's on Schoology. It's just going to go over what we just learned right now.